Good morning, everyone, and welcome back to the second breakfast session that we're doing. My name's Dan. I'm going to be guiding you through today's session, and I'm not alone. I'm joined here by Ruud Toners. Ruud, good morning.
Good morning. Good morning.
Doing well?
I'm doing well. We have a very nice topic, so I'm full of energy.
I think so. Video analytics, right?
Exactly. So we're going to talk about an AI journey. It's going to be interesting. I personally think so.
Very good, very good. Before we dive into it, like I said, my name's Dan. I'm going to be guiding you through today's live stream. Introduction, who are you?
Well, my name is Ruud Toners. I'm part of the Bosch community already for quite a long time, I would say. I'm responsible for the sales and marketing within the EMEA team and have some specific functions there for the firmware and also for the AI parts and the engine inside of our cameras. So I'm going to explain a little bit more today on that story, so that's very nice.
And speaking about that story, I think let's have a little bit of a look at what the story is. As you can see, we're going to be starting off with an introduction first, which we're doing right now, and it's also going to contain a bit of some polls. I'm going to explain later in a bit of how that works, but you're going to be seeing some polls, and we'd like to get some input from you on, okay, so how do you use video analytics? Do you use it at all? Where do you use it? To feel the waters a little bit, right? It's very interesting. Then afterwards, we're going to go into your story. You want to tell some more about that?
Yeah, we're going to first of all talk about what is really AI and what is AI all about. Then we take a little bit deeper into what Bosch does with AI and how we really use AI to actually become better and more reliable on video analytics and what you can do more about it, right? So the predictive parts of it. And then we're going to look at more of an outlook to the future. What is coming, what are we still working on, and what is also particularly nice there. And then, afterwards, so let's do a Q&A together.
Exactly, because that is, in the end, the most important. I think we want to hear from you. What are the questions that Ruud can answer for you on video analytics and AI, artificial intelligence? So let's see. Like I mentioned, we're going to be having some polls and some room for questions. You're going to be seeing on the right side of the screen here, you're going to be seeing a box where you can drop any question that you have, any comment that you have. I can already see there's some people saying hello from all over the world, so that's very nice. Keep doing that. But also when you have some questions about video analytics as such, drop them there. First, we're going to go to a poll. So the poll question here is, like I mentioned, we want to learn from you. Do you make use of video analytics already? Is it a new thing for you? Is it something you work with on a daily basis? So that's the poll you're going to be able to answer right now. What do you think, Ruud? People are going to be making use a lot of it already?
Yeah, it really depends, right? So what the use case is. Some use cases are really very much demanding some video analytics usage in that sense. Mm-hmm. So others are, let's say, not that, they're a little bit more newer into that. But we see that video analytics basically in any different vertical application can have benefits. Mm-hmm. That's of course a great thing to have. These kind of benefits. Let's talk about it, and let's talk how you can enrich that even with AI. That's really the benefit, the nice thing to do here.
Exactly, because AI being the engine behind it all, right? That's where we're going.
Exactly.
I see some results coming on already. Quite a split crowd. That's very nice. So we have some people that indicate, yes, I'm quite a newbie here. I'd like to learn more about it, and we have some people that use it very often. So a well-diverse crowd. So I think we can work with that, right?
Oh, perfect. Yeah, I'm very happy to see that. Of course, people using it very often or pretty often. Of course, great to hear that and see that already. Mm-hmm. That's really something which we can. And we really want to spark an idea as well, also with this breakfast call, mm-hmm. to really push for that people start to use it more often, right? So we have a very powerful engine inside of our cameras, and it really makes sense to rely on that. It's so amazing what you can already do with that, and how you can configure and script all of these kind of things. So that's really amazing.
Yeah, and it sounds very cool. Artificial intelligence. I'm keen to learn more about it. See what it is. See if I'm artificially intelligent. Let's see.
Yeah, of course. I would say you're super intelligent, Dan. So you're not even artificial intelligence, you're super intelligent. Yeah, you didn't dye your hair. You're a natural dark guy, right? So, and you're not a blonde?
No, it's not artificial.
Yeah, exactly.
All natural.
There you go.
Very good, very good. Right, so let's dive into the second poll here. We're going to be seeing them pretty soon, I think. So the question here is, in what kind of applications do you use video analytics? So for the people that have answered, yes, I do use video analytics sometimes or very often, or maybe very rarely, where do you usually use it? Is that in traffic? Is it in parameter protection, parking management, city surveillance, or something completely different? For the people that have something completely different, after the poll, you can write in the box and let us know where that is, so we can see that later. That'll be very interesting to know, to see more about, okay, where is it used, right?
Exactly, yeah. Already quite some interesting results coming in here for perimeter. I would say perimeter is really where, from historical reasons, we are very good and very powerful with our IVA. And our IVA is extremely capable for perimeter kind of application. So I'm happy to see as well that people dialing into a Bosch breakfast call also support that as well. I would say we even have much more kind of capabilities nowadays with our engine. So we can do even more outside of even, let's call it just perimeter protection.
Mm-hmm.
The perimeter is not easy, don't get me wrong. It is actually quite complex to do it in the right way. But we can do even more things nowadays. So hopefully I can spark that idea. So that's very nice to see.
Very interesting. Let's dive into it.
Yeah.
Right, so as I mentioned, logistics, there's a box on the side. If you want to scan the QR code as well, you're going to be able to answer the polls and ask any question on your phone. You can watch the stream in full screen, if you will. I would definitely recommend that. And if your stream would somehow stop or there would be any difficulties, please hit refresh on your browser. Usually that helps the problem, and otherwise let us know. Right, good. So these are the polls that we just mentioned. Then I think we're going to kick off a video first.
Let's do it.
Right, power to predict, beyond video security.
Exactly. So power to predict, this is our main team, which we simply have. Because we simply want to move gradually to more kind of predictive applications, right? So in the past we had cameras, there was an incident, there's a human review, right? So checking for the incident, and afterwards we already discovered quite quickly that, hey, if you do it on some analytics, also motion basis, that you can only then search for the events which are simply only there for your interest. So that is more assisted kind of review. We are now moving and already are more in automated review. Okay, there is an incident, somebody crosses a line, or somebody, let's say, blocks an emergency exit, or that you simply can see, okay, who did that? And you can already then instantly play back the video or get an event onto a phone or to a management system. So these kind of things are there. And that will slowly and gradually go more to predictive kind of solutions. Predictive meaning, hey, our two streets in a city, on this street there's a high level of crowd, and on the other street there's also a high level of crowd. Maybe there's an event, right? So there's something which is happening. So there's a crowd gathering there. So you can already do some preventive actions. Or maybe in a store, right? So you see a lot of people parking cars. So it's the occupancy rate of a parking lot goes really much higher. Therefore, you can simply say, wow, it's really getting busy in the store. Let me also already start to put already some cashiers extra there, because they will run to the store and to the shop, and eventually they will, of course, also want to buy everything, right? So they want to pay for it. So I need to have more cashiers. So this is kind of predictive kind of solutions. Yeah, we are having, let's say, all the tool sets in our shopping basket for that one. So that's a nice one. Yeah, of course, we have a lot of different hygiene factors, as we call it. So we have high image quality, right? So on our cameras, that's a very important thing. So ease of use, a lot of UX parts. We, of course, need to be efficient, and yeah, also having more, let's say, data security aspects as well into our camera solutions, right? So that all really matters, and all is very important to also have. So yeah, these kind of things brings us more to the predictive story. Yeah, and that you can all get that with AI. So we have a full AI-enabled portfolio, and yeah, we have a menu of different video analytics you can simply select. More onto that, so we're going to explain that. Yeah, but we also have a lot of connectivity kind of solutions into our portfolio. So that means, yeah, what we like to call ourselves the Greenway Promise. This means that every Bosch camera has a capability to connect itself to the cloud. If you want, you can connect it to the cloud, right? So you need to simply give it the opportunity to do that. This is our remote portal. The remote portal then allows you to remotely view the camera, configure the camera, do analytics, remote commissioning, for example. You can set it up remotely. You can do all these things simply without stepping really physically into the car, which then also makes it more green in effect. So we have even a VSaaS solution, so video surveillance as a service. Yeah, so you can really secure your investments there. So as mentioned, relying on the data, data security, super important for us. A lot of attention in our company to that. Last breakfast call, we had also quite an interesting, let's say, team there on data security, explaining more onto this IEC standard, the 62443. Okay.
A very good number. Yeah.
Great. It sticks in your mind. So
exactly. And I think for data security, for the people that didn't see the last session, you're going to be receiving a link later on to the recordings of that session. So if you want to go back and watch that, you'll get it in your email later today.
Okay. Yeah. Thanks for adding that. So onto the data security and also relying really on the data. Yeah, our deep learning AI engine has a more than 95% accuracy. So it is really quite capable and powerful what we can do with that engine. So that's really good. So
that's really the basis what we build on, right?
Yeah, exactly. So that 95% is something which we really want to push even higher. We want to push the bar. Of course, we clearly see that we want to simply make our neural network more powerful and stronger. So it's a growing kind of number, let's call it like this. What already our AI and what we are now doing in different POCs, this is very much respectable already what we can do there. So it's quite good. Let me continue with convincing all of you on that one. So our AI-enabled camera portfolio, yeah, we have different form factors into our portfolio. We use common product platforms. Maybe some of them know that already. We have a CPP 7.3, we have a CPP 13, and we have a CPP 14. And these are common product platforms, and they are simply used in different form factors into our different cameras. So, yeah, and some of them we have it in fixed dome cameras, you have bullet cameras, we have moving cameras. We have moving cameras for extreme use, our Mickeys. We have multi-imager cameras, so multi-sensor cameras, panoramic cameras, and also thermal moving cameras even. And last but not least, we have also box cameras. And all of them are, to a certain extent, AI enabled. So they are AI enabled by using a common product platform into that sense. So, and that's a huge benefit there, which we simply have. So more to explain on this, what we have as a menu to select AI from. So we already have AI really as a standard into our portfolio. So it's since 2016. We started off with essential video analytics. Essential video analytics on the more lower levels in the portfolio, already very, very capable. You can do object detection, line crossing, simple solutions, which really can already benefit a lot. But not even only simple, I would say. It's also counting you can even do with that. So a lot of different occupancy kind of scenarios can be run with this analytics as a standard. Then we started in 2019, which also as a free, let's say, tool, we have now the camera trainer available. Camera trainer since 2019 there. It's a machine learning algorithm with a small data set which you can manually train the camera with. You can start teaching it what kind of objects you want to detect. So simple objects to detect, to train it for, and then it can recognize it. You can train it, for example, for, okay, you know what, like how a barrier looks like, then this is a barrier, and this is the open state, and this is the closed state. And then you can give the state simply to camera trainer, and then you can see what kind of detections or alarms you can simply do with that. And that's a huge benefit there. And nowadays we are really into the level of deep learning AI. Deep learning AI, since end of last year, so end of 2021, we started with that. We have that in our portfolio with the OC models, and the OC models really have the best of the best kind of analytics nowadays. So it's really cutting edge, and that really is very beneficial for different applications.
Exactly, and we're going to go into these applications some more, right?
Exactly, yeah, we'll dive into that once. Yeah, and then, the question is, of course, and a lot of people ask themselves, will AI rule the world, right? So will, in a few years from now, with all these AI developments, will still we be physically here behind this desk? Or will we simply be replaced by robots on
one day,
moment?
maybe.
One day, maybe, yeah. I don't know. It's really something which of course a lot of people look out to. I think it's a little bit far-fetched, honestly saying. So I think we'll still need to have some human skill sets to a certain extent.
I can keep my job, luckily.
You can keep
Happy
your
to
job.
hear that.
Yes. We still need definitely a host for these kind of breakfast calls. So that's
good,
of course, without any doubt. No, yeah. The thing is, AI is very good in the data sets where you train it for, right? So in this example, you see here a screenshot of Microsoft Excel, right? If you start typing the month and then you have this little bit of machine learning kind of algorithm behind it. Well, it's maybe not really good. I don't think we have really a January month, for example, right?
No.
So that's not really in the best way done by Microsoft Excel. Yeah, so we still are able to teach AI more and more, but to really reach the creativity and the ability of human thinking, that's a little bit far-fetched, right? So you need enormous data sets for that. And the data set simply, that's not really possible to run with the computation power we simply have. So talking about artificial intelligence, right? So artificial intelligence is an umbrella. So it's an umbrella for different technologies. So saying AI, actually, you are saying a lot yourself. You're not just simply saying, well, okay, this is just this part or this chip or this something. No. It's a so let's say technology terminology, and yeah, we can really apply that to, for example, AI is also computer vision. Computer vision, which we are using in intelligent video analytics. So that's a computer vision algorithm, so to say. Camera trainer is machine learning. That's also AI. So a neural network which we run in the traffic detector, but also with deep learning capabilities, that neural network is really what we do now with our traffic detector. Yeah, and for example, a language processing kind of algorithm, so natural language processing, that's also AI. So a lot of different parts of it you can already quickly put under an AI umbrella, so to say. It's a technology umbrella. So that's already one thing first to understand. Yeah, we have a lot of different parts which are in AI important to understand. So AI is all about, let's say, giving a known piece of data. So you simply say in this right graph, for example, you have a known piece of data. You simply say I have different pieces of fruit. But I already labeled, for example, the tomato in this selection of different fruits. So visually, you label it as a tomato. That means that there's a AI engine who already built a neural network. The neural network talks about the different connection points in this whole, let's say, neural network setup, and then will simply output, okay, this is a tomato, because I learned from now with the labeling parts and the known data set and the labels, I know what the output needs to be. So I can build myself a decision scheme how to get to that. And that's really where the AI really comes into play. So that is really that known data, the labeling, and the data set, which is then the terminology which we need to use. The data set is then determining how good and how strong basically the algorithm is. And talking about the data set is within Bosch and our AI engine, we are building that up with 2.5 million images from different applications. So, and where, let's say, 500,000 is already coming out of traffic scenes. So it's a data set which is already growing and growing. And you can imagine all these images can build a huge neural network. And a very huge neural network, you can simply run that into the camera nowadays. So because that ability is simply there, because our SoCs and our platforms are so incredibly powerful that we really have the hardware accelerations in the unit or in the camera to run the neural network. And that's a really big benefit there. That's why this really pays off and has this really amazing results.
Yeah. You mentioned 500,000 images from traffic scenes. What other kind of images can we expect there? What is being used?
Yeah, these are different, let's say, persons, right? So persons with the different poses you can expect. You can also expect, for example, different scenes from different trucks, from different angles, from cars from different angles. Right? So these are also partly then traffic scenes.
Warehouse stuff, maybe?
From warehouses, yeah, exactly. Yeah, different backgrounds, different sceneries, but as well always linked to cars, to trucks, to bikes, and to buses, for example. So that's really where our AI engine is trained for.
Yeah.
And yeah, so they have different use cases and with different kind of environments to make sure that our neural network is very, very strong. It's already quite big at this very moment, but we have enough horsepower in the camera to really run it. That's the beauty of it.
Nice. And it all comes to the customer for free.
Yeah. Basically, we have all these kind of capabilities in our offering, right? So our offering is starting with AI, with intelligent video analytics. Intelligent video analytics is very, very good at perimeters. That's really the algorithm which we have already the longest into our portfolio. What it can really do in a very unique and good way is detect groups of moving pixels. And that is super crucial and also very useful still in perimeter kind of applications. Because the moving pixels which you actually are detecting, they can be relatively small. And an AI engine already needs to have a certain shape or a modeling or a contouring of, okay, this might be a person or this might be a car, right? So that means your object size, which you actually are detecting, needs to be slightly bigger, and that also has a distance impact. Mm-hmm. So IVA in a perimeter application where you really want to see very far away still has the bigger benefit there. So looking at camera trainer, this machine learning, already is a different kind of algorithm. You're already teaching it the contours and the shapes of what a certain object needs to be detecting, and it can also even be a wheel of a car, for example. So you can have parts of it, right? So or the wheels of a train track, or that you really can do some counting there of these kind of applications. So different applications, very specific, which you can do and which you can do with machine learning. But the machine learning is simply with 100 or 200 images. Already you can do some basic machine learning, right? So it's already by selecting different objects into a live video feed or some recording, you can then start to train already this machine learning, and then you can start doing these kind of detections. So that's a much smaller, let's call it in the data set part, it's a much smaller data set. And comparing that to our AI, let's say deep learning AI, which we have already in the camera now, with our traffic detector, that's something which is quite nice and unique, I would say. So that's a benefit there. Yeah, so different parts into our offering. So, and I already mentioned, AI, the data set is so crucial and so important. And that part is also something which comes back from Max Welling. This is from the Amsterdam Machine Learning Lab. He simply said, big data is to AI what fuel is to engines. So if the tank is empty, the engine comes to a halt, okay? The tank is not empty on our end, but we want to see a continuous feed of more video, more data. Yeah. As soon as you have more data, you simply can enrich your neural network, and you can only make it stronger and more powerful.
I just hope that the price level of big data doesn't follow the price level of fuel, because then we'd be having an issue.
For the time being, not yet. So no, definitely not. So it's a nice analogy here, right? So, but let's not follow the fuel prices here.
Exactly.
All right. That would not be good. No, but going back to that data and that gathering of data and enriching our data sets, we find that so crucially important. But as Bosch, we want to do everything also via the GDPR scheme, right? So it needs to have. We want to train our neural networks and pull it through our AI engine simply as soon as we have an agreement in place. So the customer needs to agree on, okay, I'm ready to hand over my data, and Bosch, please use your data and train your engine with it. Okay, so he needs to sign off on that we are ready to do that and to use it, and we will use it globally then. So we use it also for other customers. We just want to enrich that. But we need to have the consent to use the data. So we don't want to simply take data simply from people who simply send, here's some nice video clips, here you go. No, we need to have that signed off with a data transfer agreement. Yeah, sometimes we also use some of the public data sources, deposit photos, Shutterstock. You can buy already the rights for this kind of video footage and then also use it in your AI engine to start training for that. So already we're doing that and also continuously enriching via these kind of media. But sometimes we really need to have scenes from particular applications. That's important. Because what we do is, as soon as we get that data flowing, we are simply saying, well, okay, here, this part of the video, we do some data curation. So we say, okay, 30 seconds of this clip, because we don't have that. We just need 30 seconds of that. because 30 seconds is already growing quite a lot of different images per second there. Because what we do is we need to label that. And we need to label that because we need to define in the video what it should detect. So this is the input and then the data set needs to be created with that labeling effort. And that's really sometimes with a certain engine and pixel by pixel, they need to really start drawing, okay, this is where you need to detect because this is really where a bike or a car or a person simply sits. And then you need to get that. So the labeling is super important to have that push through. And yeah, also very time consuming, as you can imagine. So as soon as we have that labeling done, which is the most difficult step, then you can simply pull it through the training of the engine itself. And then we can evaluate, okay, did we actually make it better now? Because we have a nightly build onto our AI engine as well. And then seeing, okay, did we now, with injecting all that data, did we make it better? Or did we actually make it worse, right? So we need to post-evaluate that. And as soon as it's basically better, which is most of the times it is, then simply you integrate it in the product. So that's a little bit the way how we work with our data sets and injecting more data. Very important there, yeah. Talking a little bit about the synergies. So the synergies of between the business units. So yeah, we have a lot of different kind of technologies within Bosch, and yeah, we're quite blessed with the fact that we have automotive as well behind us. So within Bosch, automotive is a big group, right? So and within automotive, they need a lot of video analytics, and all that video analytics they are making and developing. Simply, we can also benefit from that from building technologies. So they are simply developing all these crucial parts in their engines and in their frameworks. And we can simply also benefit from that. And that's why, yeah, we have quite a nice and powerful AI engine already because we have a lot of data. You know, making use a lot of, let's say, development power.
Yeah, making use of the power of Bosch there.
Yeah, yeah, absolutely.
And then for the automotive part, what do they use it for? Is it like the onboard cameras in the cars, or?
Yeah. Exactly. So nowadays there's a lot of, let's say, video-made decisions based in the car. So sometimes it's even some crash predictions. Sometimes it even works together. Then the video pass together with a radar detector. So that you use the both sensors in that sense. But the video still has a lot of computer vision technology there. Exactly. And that computer vision technology is supported by our common, let's say, corporate research team, which is sitting in Hildesheim in Germany. So they are for the people which are old enough, they in the past, I also had a car with a car stereo from Blaupunkt. Okay, that's where actually this was the corporate, the Hildesheim division was really the Blaupunkt facility there. But we still now have a lot of, let's say for the existing car stereos, there's still a lot of development there, and that then cooperates a lot with the video team there. So, yeah, computer vision team.
Interesting. Yeah.
Absolutely. Yeah, and one of the things which we are also working on as of today is really high precision detection using a PTZ camera. So that is using AI. So on the left-hand side, you see our AI engine plus IVA, because IVA is very good in tracking objects. And on the right-hand side, you just see the AI engine. And on the right-hand side, if you look to this, it really sometimes loses the object because it says, it's a person. Oh, okay, maybe it's not a person now at this very moment. But the beauty of it is our IVA knows, okay, hey, it was a person. Likely it still is a person because this tracking follows the object in a very good and precise way. And that's the huge benefit which we have with this kind of tracking algorithm, that we use both technologies. So it's two technologies in one. So it's an AI engine plus IVA to really track and to see, okay, this was an object, it was a person, so it still is a person, right? Even though I quickly lost it for a millisecond there. And that's giving a lot of different robustness onto the tracking algorithm.
It's working side by side there.
Yeah, exactly, side by side together, and they simply work together as one overlaid kind of algorithm. Yeah, cool. Yeah. And that's already something which you can also see in action with a different scene. There's a traffic scene, for example, which is with our new to-be-released product, so an Autodome Intake 7100. So this is, let's call it a beta firmware, I would say still. But here already we did a quick test. Okay, we had this camera installed in a PUC, pointing it simply onto the bus and giving it an on-click. So simply saying, on-click, follow the bus. And then you see really that the PTZ simply follows the AI object in a very nice way. It zooms in, it zooms out, it tries to puts it really off the center of the screen in a nice way. And that's really then the AI engine doing all of this magic. And that's a very nice thing to see.
Yeah.
We are really, with our AI engine, able to do that kind of precise tracking. Because the huge benefit here is that as soon as you have an AI engine tracking instead of an IVA engine tracking here, as soon as the object becomes static, so this bus stops for a certain time being, it will not become part of the background immediately. And that is typically what a background learning algorithm does, like IVA. But an AI engine simply says, okay, it is a bus, it's standing still, but it's still a bus. And then it stays spot on.
Yeah.
And then it simply starts again, driving in front of the traffic light in this example, and then follows in a very nice, precise way. And that's the beauty of an AI engine, that you can do this kind of additional, more precise detections.
Mm-hmm.
Yeah, something as well as a sneak peek into the future. So we are also working currently on a zero effort calibration engine. Zero effort means you just install the camera, you point it to a road. That needs to be a road scene then. You see a lot of cars, so it starts already by the detection, see that there are certain cars on the road, right? So this is with the 3D vision and the modeling which is simply there. And with that, it starts to already simply say, well, okay, the cars are moving in this plane, likely this is the ground plane, likely this is my tilt angle, maybe this is a little bit of a roll angle as well in that sense, and it starts to auto-calibrate. And this is what we like to call zero effort calibration. So that is also something we're working on. Hopefully by beginning of next year, we also will add this to our portfolio. Just point the camera, no need to calibrate into a traffic scene, and simply you can already run off with it. So that's the beauty of it.
And this will then be implemented in future releases of cameras?
Yeah. This is on the future releases of the cameras. So the AI engine, which is then coming by beginning of next year. It will be an update.
Exactly.
Yeah. That's the beauty of it. All right. Small video about our AI engine. Exactly. So, yeah, we're sorry to wake you up with this nice music and powerful, strong music in the morning. But yeah, what we are showing in this video, we have a lot of different capabilities into our analytics engines, which are simply a huge benefit to what we simply bring. So, more onto what kind of applications we are simply foreseeing, and yeah, we are going more and more, and that's also coming then in the second half of this year. We want to go with a packaged approach. So our new products and our new cameras, which we will start launching, they will come with an AI package, which we like to say as AI as a standard. So that means AI as a standard is normally on the product already. So you can do simple detections like a person detection, a car detection. You don't have to calibrate because there's the speed and the geolocation is not there. That's also a very simple setup, I would say. But still, as soon as there is a person, you can still draw a privacy mask over it. So basic AI engine, a very strong engine, which you can simply use in a city already or in a small retail store, counting persons, stepping into the scene, on the parking lot counting cars, very simple, but very, very powerful already with our AI as a standard. So that's the first package which we have upcoming. Then as soon as you want to have really perimeter kind of applications, and in the perimeter kind of applications, we will go with that package there. So that will go more into the direction also with this automated calibration. With the automated calibration in 2023, that will be launched. So we can detect also crawling and rolling on the floor, for example, these kind of things, which is really then where IVA also excels into. So IVA, it will be the main part for this engine, but it will package it at perimeter security. And do you want to have the best of the best and the most powerful analytics? Then really we have the road and safety, road and traffic intelligence package. So that package with which will be 95% accuracy in busy traffic scenes, automated calibration as well there. So as I've shown with this video, and then also very reliable and also getting anonymized data, for example. You can also do privacy masking with that sense, and that's the beauty of this kind of powerful engine. And that's really is the most powerful part which we have. Yeah, this traffic detector, as we like to call it, it has the capability already to send the GPS data. So the GPS data really of the object itself in front of the camera. So if you have a car which is driving, we can geotag the object with the coordinations and then simply send that to a management system, and the management system can then draw the object onto a map. Mm-hmm. That's the beauty of this geolocation. So speed, also very important. The speed detections you can do also then in a very precise way, I would say. It's not for really enforcement ready, but already you can do already a decent measurement there. Yeah, and the direction you can also then pull into. Yeah, we can distinguish then on the classification, trucks, bikes, motorbikes, buses, cars, different, let's say, classifications there. Yeah, we also want to grow the number of classifications. Again, is a data set and a data set question and input there, which you like to have. So pushing more of the capabilities into that. But at this very moment, these are the classifications we are fully focusing on to. Mm-hmm. And the beauty of this algorithm is as well, it works very nicely into crowded scenes. So if you have a lot of people walking in front, they really can be detected in a nice way. So yeah, some parts of the videos I have here. So just to prove that a little bit. So we have here a video where we started a POC with quite early already. This is with the city of Columbus in the US. There they had a need to get statistics for the different intersections, so throughout the city. And on these intersections, yeah, you can really start to count the cars, the trucks, the persons crossing the street. So really statistical data you can simply extract from these kind of use cases. And that's a big benefit with this kind of, let's say, algorithm and the AI engine which we simply have in our cameras, that you can really detect that in a very proper way. So that's a very powerful part, and with a very much a traffic use case. But with a traffic use case, I mentioned as well, it can detect people in a good way as well. And yeah, detecting people, hang on, let me do that. So detecting people in a very nice way means, yeah, you can detect it really and segment it in this very busy scene. So in that very busy scene, you can simply see persons and people being, yeah, let's call it split up, because they somehow occlude, right? So they are half and half in front of each other, but still we need half a person to simply detect it in a good way. So in this scene with a little bit perspective, already we can detect that in a good way. It's not playing the video, sorry for that. Yeah, looking out to what we also are getting in the traffic detector in what we like to call 2.0 is also where we are still working on. Outlook to the future. So better performance. So better performance meaning that we sometimes also see in pitch darkness, and you see cars going onto a highway, for example. On that highway, there's no light, there are no traffic lights, and that means that you don't see the shape of the car. And if you don't see the shape of the car, then the AI engine expects at least the shape. Mm-hmm. So then an AI engine is not really up to the most performant there. And what you then are looking for is a little bit of a fallback method. So you want to have a fallback method because you see the headlights, and you see two headlights actually approaching the camera as well. And likely as soon as you see these two headlights, then likely it is a car, right? So you see one headlight, it's a motorbike, or a car with a broken headlight, but exactly. At least that fallback is simply there. So for very tough situations, it will make the situation more robust. So that's what we see there. But yeah, the engine itself performs the best as soon as you have really the best, let's say, light situation there. So some street light. If you have just a little bit of light already and you see some contouring of the car, AI will do the job. So that's typically the best thing there. Yeah, we also are optimizing our 2D tracker, technical name for it, but the 2D traffic detector, so in the two-dimensional side of things. So we optimize it, for example, with better handling of the stationary objects, meaning longer parked objects. They are better classified in that sense. So there's some simple benefits there onto the tracking and handling there. So yeah, that's something we are doing. Then also quite important is that we will add the 3D width, height, and the length, and that's very beneficial for truck kind of sub-classifications. So for a truck use case, you can also use it, for example, for the height to give an early warning. Hey, this truck which is now coming, it doesn't fit to the tunnel, which is actually 1 kilometer further ahead. So I need to simply warn the truck or pull it off the road, or let's give an early warning to that. So that kind of use cases we also see with that. So the PTZ cameras, the intelligent tracking, also the tracking while doing a movement. You can also still track objects. These kind of things we're also working on too, as I shown in the video. So this is all coming, and then talking about platforms, CPP 14. This is then the third quarter this year still. And for the CPP 13, we're doing that in the fourth quarter, so this year. So we see some nice updates ahead. So that's nice.
Nice, cool.
Yeah. Then talking about, and I mentioned that already. I gave it away. So deep learning AI will become a standard for us. So in future, our cameras will have deep learning AI as a standard. We really see and we believe in this technology. We will push it out and put it per default onto our products. Do you want more features, more, let's say, capabilities? You can buy upgrade packages, but AI will become a standard. And that's very nice and very important to understand as a takeaway. Also, what is important to understand, we also have audio analytics which are coming, and this is also an AI engine for our panoramic cameras. So panoramic 5100 series has 3 small microphones already in there, and you can do a gunshot or a glass break detection also with that. It's not yet there, but we are working on that, and that's also still coming.
That's very cool, right? For a camera to be able to detect audio and also classify it.
It's super sexy. Yes. Yeah.
Maybe just to us.
Yeah. Yeah, exactly. All right. Then moving a little bit into something which also is extremely interesting. I personally think so, and that is called calibration, map-based calibration. So sometimes you need to calibrate a camera because you want to have you want to tell the IVA or you want to tell the AI engine what the 3D view is of the particular camera. You want to tell it, okay, this is the installation height, this is the roll angle, this is the tilt angle, and then, if you don't have this zero effort calibration yet, which you don't yet have, or you don't have it really as a capability maybe in that particular camera, then you need to calibrate anyhow. And what we can do is we can do that map-based, and I will demo that.
Yeah. While you get your laptop set up, indeed, we're going to have a look at a small demo. In the meantime, like I said, if you have questions, drop them in the box below or on the side of your screen already, or if you scan the QR code, open your phone, drop the questions in there. We're going to be going to the questions after this demo. So drop them there. We'd like to see what you took from this and where you're going with this. So we're looking forward. Now, first, you're going to show us something.
Yeah, let's do actually a quick demo on this, what we can do with map-based calibration. And that's quite nice. I have here, let's say, a tool, and this tool will become a standard in the configuration manager. Configuration manager is a configuration tool which you use to configure Bosch cameras. You can do firmware updates, you can change settings, you can do even batches. You can multi-select 20 cameras and change one particular setting of all 20 cameras in one go. But we also will upgrade that config manager, that free of charge tool, with this map-based calibration engine. It's not yet there, so at September time frame, we expect this to come also in the new version of the configuration manager. But what we can do with this is really this calibration. So this is just a demonstrator as a standalone. And what I can do to demo, I have this laptop. The laptop is connected to the Wi-Fi, so I have an internet connection here. And what we can do is we can connect via remote portal to one of the cameras. So this camera is here also based in Eindhoven. And this particular camera will start to live stream already, and I see that here on the bottom of the screen, the video. And I can select, okay, I want to do a standard calibration, which is the current approach, but this is really something new. I can do it map-based. And map-based calibration gives you very nice benefits. So let me continue and selecting map-based. I first of all need to say, well, where is this camera located? I will type, for the sake of demo, I will type it as a new location. I will type Torenallee 49, press enter, and then it will say, right, so this is in Eindhoven, Torenallee, this is a here map engine which is used for that, and it will find already the location there. So I will create a location. Location is created, and it will start to already give that here on the map, simply there. So I see the map data and our office. This is the Bosch office which is there, where on top we have a Bosch camera installed. Yep. And this is the video feed of the camera. So continuing this, I would say, well, okay, the camera doesn't have distortion. No distortion, the camera gives an even plane feed. So I will simply skip through that and simply continue with the whole setup. And here is the beauty of it. Here is where we can do map-based calibration. So map-based calibration means I want to calibrate because I want to put value here to all these 7 values. So latitude, longitude, the direction, the height, the tilt, and the roll. And how we do that is simply by selecting here, this camera is here installed on top, but it has an outlook here to the parking lot. So what we can do is we can start dragging in pointers. So I can drag a pointer simply saying here, okay, this part of the road is point number 1, and point number 1 is exactly also here on the map. So it's also point 1. So you can also say, well, okay, this corner of the building here, point number 2, is over there, and the corner of that building is over there. I know the site a little bit. So this is point number 3, which I can select here on the other side of the building. This is also point number 3 there of this building, so on the map. So I already have now 3 points, and I can also put now a 4th point. Let's take this part of this hedge here, which is point 4 here on this hedge, and then point 4 here on the hedge. And now it starts already to triangulate, right? So this is really the beauty of it. So by giving 4 points in the live feed, but then also relating it and connecting it to GPS data, we can already triangulate really where we're looking at and how to calibrate it. So I can verify already giving a little bit more data to it. So I can see here the live video moving through the GPS data. So here are the parked cars. There's no car moving, but even if you do, you see it on the street. The hedge here of the live video feed is also connecting into the hedge of the GPS data. And that's already a nice confirmation that actually the calibration is quite well done. I don't see any shifts of the live video feed versus what I see on the GPS map. And then what the nice thing is, already with these 4 points, and you can give more points to make it even more precise, but with 4 points already is able to triangulate. So the triangulation here gives already that I have a latitude entry of 51.4, right? Longitude as well, full GPS coordination there. So I have a direction, because the camera, I know the direction where it is looking at. So that's also simply given. The height, the installation height is on top of our building, so that's really 44 meters high. So we have quite a high 10th floor building. So we have a tilt angle of 16 degrees. So we have a roll angle of -1 degree, and we have a field of view setting of 50.
And how does it know the height in this case?
Yeah, that's really the beauty of that. So the beauty of this is that you really connect these different points there, and it really can triangulate the points with the GPS data and the distances. It knows already the offset of the height. And that's really the beauty of it. I really connect 4 points in the physical video versus into the map, and then all that triangulation will start to populate the different values. Yeah. And that's a very, very nice thing.
Anyone can do this.
That. Yeah. Yeah. So these 7 values are all provided simply by this nice trick, which we simply can do here. And the beauty of this is this also will work on more legacy-based cameras. So this map data. But you need to have structural buildings, right, to do this kind of calibration. It's not that you can simply go into the forest and simply say, here's a tree and there's a bush, and then in vegetations, you cannot rely on GPS data because the picture itself, is not really relying whether was it this bush or this other one.
Right.
So you cannot simply see that over time because it's a momentarily kind of picture which you have right, from that particular moment. Right, so this is very nice. So in the third quarter, we will make this happen. So this will become a part of the configuration manager, and you can use it for different Bosch cameras. And the beauty of it is it will already populate the data set itself. Because if I now click finish, it will write these 7 values in the camera, and then off you go. So data is written, camera is calibrated, and then it will start to give also geotag kind of capability. So it will geotag an object. As soon as it detects a car, it will give a GPS coordinate with that. That's a very nice benefit with that. So in your metadata stream. Sorry, I'm very excited about this.
I was going to say, I can tell you're very excited. It's your baby.
Yeah, absolutely. All right, good. So far for the demo.
Exactly. I think that means we're going to go to some questions, right?
Absolutely.
Yeah,
ready for that.
So I do see a lot of questions coming in already. I'm really happy with that. I think it's an interesting topic, and there's some good questions coming in. I've been scanning them. So keep them coming. We have plenty of time, and otherwise we'll come back to them afterwards for sure. So first one I see here is, will your AI be implemented in, oops, it moved, in the new FPGA chipset or be available as an add-on?
Well, okay, that's a nice technology-based question. So currently we have an FPGA which is built into our cameras, which is an accelerator for our analytics. Mm-hmm. But nowadays we need to have neural network accelerators built into our cameras. And unfortunately, as soon as you look to our CP 7.3, which is having this kind of FPGA built in, we don't have that neural network kind of accelerators built into that existing platform. So you need to use the CPP 13 or the CP 14 based cameras for that to really do something more with deep learning AI. So unfortunately, the answer here is no. This is something where we are restricted to with our technology platform, which we simply have.
Right. Yeah. Here's someone else that says, can we calibrate the camera with this new calibration method, even if there are different ground levels? So as an example, they say 2 floors in the parking building or stairs or something like that. Okay,
a nice question. I like that. It is actually quite difficult. This is something which is developed really for a ground plane level. So with elevations, the ground plane is not capable to triangulate it there. So that is the basis of the triangulation, which is simply there, that everything is flat. Okay, if you have elevations there, then at this very moment we are not able to offset the calibration engine for that. That is also on the roadmap later on to also get that added. That you can simply say, okay, this part is an offset area, but we simply also see that we have a higher level. But at the moment, it is starting off with a ground level.
Right.
For the Netherlands, it's fine.
No problem.
No problem. We have a lot of flat ground here, so.
Exactly. I know I like to be strict with you. You said it's coming on later in the roadmap. Any idea when?
Oh my God, I need to check that. Already we discussed it with product management at least, that we need to work on that. But I would say initially, it's in the pipeline, but I would say something beginning of next year. I would expect so that we can update our calibration engine, hopefully.
Exactly, good. So someone else here is saying, and it's a nice challenge for you, I think, would stereoscopic view not simplify analytics? So having 2 sensors slightly apart watching the same scene. Is there any research or development in that field of technology?
Right. So with stereo vision, yes, we also have actually with our automotive colleagues, we have a product actually there. So we're doing automatic valet parking with our automotive colleagues as a pilot. However, we clearly see that the majority of the cases and where we are strong into is really the more, let's say, kind of traffic kind of solutions, the perimeter kind of solutions. And of course, within retail, stereographic is very nice. But we also see that there's a high price point pressure from that side. So yes, it is investigated still what we can do with stereographic. But at this very moment, we really see that we have security cameras for security applications. And around the security applications, we can give that extra capabilities with our AI engines.
Right.
So stereo for us is something which we see. It is a trend, but it is pretty contained still.
Right.
Pretty small. Yeah.
Right. Okay. What about tracking other kind of objects? So for example, not persons or cars, but what about containers? Something like that.
Yeah.
Other types.
Exactly, yeah.
Learned by camera trainer, in this case, it's added.
Yeah, if you want to detect that with camera trainer and it's a containable kind of application with not too many variations, then I would say camera trainer could be a resolution to that. If you want to have it more on the open street and you have different variations which you want to simply detect, and also we see that now with the trucks and the detection of the trucks and the length of the trucks, that's also a difficulty because you have trucks with containers, you have trucks without containers, you have trucks which carry logs of wood, so it's also...
Or even another truck on top.
Yeah, or just also cars, right? So it's quite complex in that way. So the shape of a truck is challenging. So we need to train our data. We need to get better into that. Detecting a container is also about the application. Yes, so we need to have the data, we need to have the footage, and then we can add it also to our engine. So as soon as you have the data and the labeling, and we need to have that signed off, then we can add it to the AI engine as a data set, and then there can be an application there. But that needs to be evaluated a bit. So because we need to look at it, okay, does it make sense? Will we do the effort? Does it make sense to open up a new market or a new business model for us? That would simply be good. Yeah, I like to do everything, right? So whatever is capable, I like to do that. But I'm not alone in the company. We need to also have some consent from others to really pull some developers away to do that. So there needs to be a little bit of a business case there.
Exactly.
Yeah.
Good. So there's someone asking here, how is the performance of the DNN during night using cameras with IR illumination?
Yeah, very good. Yeah, so we also train for that. Let's say like this, or train for that. This is part of our data set. So our data set has also the situations at night, how to detect cars with with the lights on, with the different road light situations. So all the different variations, we try to simply also embed that there because we want to make it robust. And that means at night times it also needs to perform. So yes, IR, night times on, the detection also will perform, yes.
Perfect, good. Let's do two more. I think there's very nice questions coming in, so it's a waste not to address them. Are the AI features offered as a build in the camera itself, or we should buy a separate software package and running on a separate server?
Right, so today we are having two solutions there. So yes, we have AI, and we have AI with IVA and with camera trainer, but we have deep learning AI as well. And that deep learning, the deep neural network technology, that is currently in the OC models, so the object classifier models, which you simply have in our portfolio. So there's our fixed cameras, which are OC capable, and there are Mickey cameras, which are OC capable, and there's also an Autodome 7000, which is OC capable. And we get more of this in there. However, as I announced as well, we are changing the strategy a bit there, because in the future we will go into the packaged approach. So we will have on the new generation of the cameras coming, we'll have that with AI as a standard, and then as soon as you want to do more, you need to buy an additional package.
Right.
But for today, simply we have an OC models in our portfolio. The OC will have that deep learning AI engines and will simply get all that benefits which I just showed.
Exactly. But so in the future model, if I understand it correctly, you get a basis, and then you can actually buy the thing you need. So you won't buy for all other stuff that you won't need. You go for the scene that you want.
Correct.
Right.
Yeah.
Interesting. Last one. What is the smallest package that the system can track and the distance of the pack from the camera? So I think the smallest type of object that they can track.
Oh, wow.
Can we do ants, basically, is the question.
Oh, yeah, we got some detailed questions here.
Yeah, it's nice. It's a good topic.
I like it. We have a nice crowd here asking some detailed questions. So the pixel size and the relative pixel size which you need to have, and then you talk about the skilled and the native analytics resolution. For an IVA, for example, that's something like a 5x5 pixel size which you need to have as an object, which is extremely small. So it is a very low percentage of the scene you can already do with IVA. But yeah, as soon as you are talking about an AI engine, we need something like 15 by 15 pixels. Okay. So the detection distance is a little bit less due to this size. Okay. So the physical, the object size needs to be a bit bigger because it needs to distinct, okay, is it a person or is it a car or whatever. So that minimal pixel size is a little bit of a, let's say, a difference in that sense. But we clearly see the more power you have, The more capabilities we nowadays have also with our new cameras, we can also see some gains there. So it really is a temporary issue that you simply cannot detect that far. So that gradually will become also better over time.
Nice, good. Good.
Yeah.
I see we're running towards the 10 a.m. mark, at least in our time zone. So let's quickly go to some last questions to you. If your question hasn't been answered, don't worry, we'll get back to it one way or another, perhaps via email or maybe find Ruud's phone number, give him a call. He'll be more than happy to answer any questions you have. Now, first, we have some questions for you. So if we can pull up the poll quickly, the upcoming next poll on the screen. Again, so you have... You're gonna see it on the side of your screen or on your phone. I see it in a ticker tape now. Maybe there it is. Question: how did we do? So we always want to see how this was, right? We want to make sure that this is a good experience for you. We want to make sure that we give you the information. I know that this is just a star rating. Give us an indication. Later on, you're gonna get a survey link as well in your email. Then you can tell us exactly, hey, I wanted to know about this topic, or I wanted to learn more about this. Let us know for sure. For now, I see people are already voting. Luckily, the feedback is good, Ruud. We're gonna get a salary this month.
Yeah,
it's good.
Yeah. If it would be vice versa, it would be bad for us. Yeah.
Exactly.
Yeah.
No, we can drive home safely tonight. So that's very good to hear.
Yeah.
Exactly. Very nice. So thanks for that feedback. Like I said, more feedback can be given in the survey link that you'll receive later today, where you'll also get the presentation and the recordings, and also the recording from the previous session, as I mentioned earlier. Now, as you know, if you've attended us last time as well, we don't just come up with the topics. We want to hear from you. What should we talk about, right? So what is the topic that we should talk about next? We're going to have another session in about a month. Final date will be communicated at a later stage, and you'll be getting the invitation for that. So we have a couple of pre-selected topics here. I think let's quickly run through them because they're quite interesting. One is the VSaaS. You mentioned it before, video surveillance as a service. I think that's a completely new business model. Exactly. From let's say recently in the market, and how to work with that. We have of course tracking people and objects in BVMS, our own Bosch VMS. That's kind of touches upon what you mentioned before. Yeah. New panoramic. You mentioned the camera. It's coming up. That's the one that also will have at some point the audio analytics, right?
Correct.
And then we have more on dashboard solutions. So the data that we discussed today, how to work that into a dashboard and make it in a nice one overview.
Right.
Looking at the results, I see a lot of people voting. Very nice.
We have a tie.
We have a tie.
Yeah.
Yeah, that means we're going to be doing a 4-hour live stream.
Yeah. Exactly. Okay.
We'll need to see. So if you haven't voted yet and you want to still weigh in on this, do it quickly. Make sure you're there, because right now it's a 31 versus 32%. So it's definitely on the software side. So it's the Bosch video management system or the video surveillance as a service. Let's see. We're going to make an interesting show for you again. We're going to get all the information together. I'll handpick an expert from the office and get him or her in front of the camera and make sure they give the information that you need. Very good. With that, I would like to thank you, Ruud. Thanks for being here. Thanks for explaining us all that you know about video analytics and AI.
It was my pleasure.
Very nice. And thank every one of you for being here again. Thank you for watching. Thank you for all your questions. And with that, I wish you a very, very good day. Goodbye.